Hello everyone, my name is Manuel Rodriguez and I will be talking about good practices for the adoption of DataOps in the software industry. So this presentation is going to be mostly divided into 4 parts. On the first part, I'm going to be talking about DataOps. What is it? What are the benefits of it? Then I'm going to be talking about which are the main components of DataOps. Then I'm going to be talking about what is the main process of DataOps, which is basically divided into 3 parts. And to conclude, I'm going to be talking about some of the steps for the implementation of DataOps in any type of company. So what is the motivation behind this research? As you can see in this image, the amount of data produced on the internet over the last 12 years has dramatically increased. On 2008, there was not even 2 zettabytes of data compared to the over 44 zettabytes of data produced in 2020. And despite the amount of data has increased, the use of this data to produce value and insight by companies has been limited. Other reasons, companies are struggling to create insight from this data is because of data errors. For example, one survey conducted in 2019 by a company called Data Kitchen to over 300 companies concluded that most companies are way too slow to deploy changes into production, and the cycle time for new analytics must be reduced to hours or better yet minutes. And that most companies have way too many errors per month. And these type of data errors negatively impact the productivity of the analytics team. So the solution for this is the creation of DataOps. So DataOps emerged to take a more accurate decision and to increase the success of a business endeavor. A data-driven process which covers from data collection to analysis and decision is necessary. DataOps is an automated process-oriented methodology used by analytics and data teams to improve the quality and reduce the cycle time of data analytics. You must be wondering, why DataOps? And DataOps was introduced basically to address 2 of the main issues related to the management and utilization of data collected during the software process. The first one is that data became more mainstream over the years. And this is because business run at an incredibly fast pace. Therefore, the data needs to move at the same pace. Otherwise, it's going to get ignored from the decision-making process. And the second one is that there is a need for a more agile process for data. This is because there is a growth in data sources thanks to the advancements in the collection from all the applications such as sensors, e-commerce, Internet of Things, and social media platforms. This is basically a very simple representation of the life cycle of DataOps. DataOps basically is a derived concept it's an extended concept from DevOps. Some industry experts can define DataOps as the application of DevOps to data. And this shows how effective data operations can be when DevOps concepts are applied to data for managing and deriving analytics. So why agile analytics are so important? Basically because, first of all, they allow quick business decisions. And these analytics require systems that can incorporate quick changes in a structured way. Because fast and precise analytics enable to make quick decisions, allowing the company to be ahead of the competition. Companies need to withstand evolving market threats. And agile analytics is mostly focused on end goals. So the recommended approach is to have only sufficient planning and adoption to change risk preparation and team involvement in order to achieve incremental development goals. This graph represents what is basically the journey of data through the DataOps pipeline. Basically, we begin with the acquisition process of multiple sources of data. We have some external, internal, in-house data. Then this type of data is prepared, then it's cleaned, then it's transformed to be sent to a destination. In this case, we have data warehouses, we got databases, and we got APIs. And with this, value is produced in the form of analytics and business intelligence. One of the reasons DataOps works is because of collaboration, and collaboration is one of the key factors here. Basically, five main participants have to collaborate in order to make DataOps work. For example, data scientists apply data science techniques that include machine learning and deep learning models, mostly through each iteration. Data engineers deal with aggregation of data and manage the data sets used for evaluating and training data models. Developers and architects create end-to-end applications that include the models created by the data scientist. Data governance define the data access and controls. And basically, the DevOps team is responsible for deploying the application into production environments. So DataOps is mostly divided into four main components. The first one is the data pipeline orchestrator, which is basically a software entity that is responsible for managing the processes, control execution of the steps. The second one is quality control and monitoring, because DataOps automatically tests and monitors the production quality of all data. Third one is deployment automation and development sandbox creation, because continuously DataOps is in charge of continuously move the code and configuration from development environment into production. And the last one is the deployment of the data science model, because DataOps-driven science teams make reproducible development environments and move models into production. So a platform that meets all these demands has to have the following characteristics. It needs to be high available and reliability. It needs to support modern data science languages and tools, must support multi-tenancy, must support for distributed architecture, and must support for linear and scalability growth within business and use cases. And a single platform approach is a key to increase the agility support for a holistic approach and reduces the effort and time required to copy or move large datasets across siloed teams or processes. And now basically the process of the TOPS is mostly divided into three main processes. The first one we can call it as the initial organization, where we got four main sub-processes. The first one is understanding the business requirements as any other software development process. Then we need to proceed to the formation of the TOPS team, which has to involve people from the business side of the corporation, from the data science part of the corporation, and the developers. Then business consumer identification, where the business team and data team need to collaborate in order to identify which are the consumers which are going to make the decisions for how the project is going. And the last step is objectives and scope, in which all objectives and scope for the project needs to be very clearly defined. Then we got the data management, where we have four other main processes, which are like the data acquisition, the transformation, the repository management, and the modeling of all this data. And to conclude, we got two main sub-processes, which are the review. With this review, it allows us to discover multiple problems that at an enterprise level mostly lay in silos. And the monitor and plan, because monitoring the steps continuously and in a disciplined fashion allow us to improve errors and inadequacies in every single step. Finally, the steps for implementing DataOps in any company are mostly 5 steps. The first one is data analysis test and automated test, because all tests should be automated, including the data tests. A version control tool helps teams of individuals organize and manage the changes, revisions to the code. That's why it's very important to use a version control system. The third one is branch and merge, because this allows teams to make changes to the same source code files in parallel without slowing each other down. The fourth one is to use multiple environments, because every data analytics team member has their own development tools in their own laptop. Giving team members their own environment isolates the rest of the organization from being impacted by the work. And the final step is to reuse and containerize, because each middle step in the data analytics pipeline receives an output from a prior stage and provides input to the next stage. And to conclude, we draw basically two main conclusions. And the first one is that building a scalable, high performance, and highly available system require a monitor and discipline approach. And that data does not bring any value until it's applied to impact growth or profitability through operational efficiency. And this is the end of my presentation. Thank you very much for listening to me. If you have any questions, feel free to write me to my email at m.rodriguez.osuna@Innopolis University. Thank you and goodbye.